This is Larry Hatcher. This is Psych 299 Statistics, and this is my lecture on Part 10 Variables in Statistics. You should have downloaded the PDF for Part 10 Variables in Statistics. It's available in Canvas. You log into Canvas, you go to Psych 299. On the left, you select Modules. That opens up the modules for this course. Go to the module that is among the first 2 or 3 modules for the semester. It has a page that lists all of the mini chapters for the current units, all the mini chapters for Unit 1. Among those mini chapters, there will be a link that allows you to open up this document. The document's titled Part 10 Variables in Statistics. I'm going to lecture on this module. The module that you have in front of you has some important terms blanked out. As I lecture on the module, as I lecture on this mini chapter, I will fill in the blanks. I'll tell you what the missing terms are. You can add some comments to the PDF document in front of you using the instructions that I provided in another document in Canvas modules. And by the end of my lecture, all the blanks will be filled in, and this mini chapter, you'll be able to study to get ready for the upcoming PAC quiz. The topics to be covered in the current lecture. The issue is variables in statistics. I'm going to introduce you to the different kinds of constructs and variables that we analyze when we perform data analyses. This is going to be mostly getting you familiar with some of the basic terminology that we use in statistical analysis. What's the difference between a variable versus a value? What's the difference between our 4 different types of measurement scales? This is the outline of topics that I plan to cover. When we're done with dichotomous variables, we will be done with this part. But there will be 2 additional mini chapters that I need to lecture on so that you have complete mini chapters for Unit 1. You'll be ready to take the quiz on Unit 1. Let's get started. I am in the same mini chapter. I'm on page 10-2, and at the top of page 10-2, we fill in our first blank. Defining the term variable. That's a term you'll hear a lot in a statistics course. Definition for variable. Variable is anything that, when measured, can produce 2 or more different scores or values. Some examples of variables. IQ is an example of a variable. Intelligence quotient. Your score on an IQ test might be 100. Your score on an IQ test might be 90. It might be 121. The fact that IQ can take on more than one different score tells us that it's a variable. Income is a variable. Your income last year might have been $20,000. It might have been $0. It might have been $1 million. The fact that it can take on different values tells us that it is a variable. A construct does not necessarily have to be a numeric quantitative variable to be a variable. Political party is a good example of a non-quantitative variable. Your political party membership might be you're a member of the Republican Party. It might be you're a member of the Democrat Party. It might be that you're an independent. In this case, we're not measuring any kind of quantity. We're just determining which category you belong in, which group you belong in. So political party is an example of a variable, even though it does not take on quantitative values. Notice I used to use race as an example of a variable. These days we recognize that race is kind of a lousy example of a variable. We used to think of it in terms of being categorical. You're either in the white category or the African American category and so forth. Today we realize that things are much more nuanced than that, so I've scratched it out. We don't use that as an example of a variable. By the time I'm done with this lecture, I will have given you many more examples of variables as well as the values that they can assume. And in fact, that brings up our very next term in this mini chapter. Next term is value. Definition for value. Value is a score or a classification that a variable may assume. For example, let's think about that variable IQ that I talked about a minute ago. I said that your IQ might be 100, it might be 110, it might be 90. These are the different values that IQ can assume, the different scores that it can assume. Income, your score on income might be $10,000 a year, $25,000 a year. These are the values that it can assume. And once again, a variable doesn't necessarily have to be quantitative. Sex can be a variable. It's a categorical variable. You might be in the male category, you might be in the female category. Back when I wrote these lecture notes, we thought of sex as being binary, dichotomous. You're either in one category or the other. Today we recognize that there's more than two categories to sex. There are folks that are non-binary. There's other categories as well, but it's still a good example of a categorical variable. So when you think variable, think construct. When you think value, think the different categories or scores that that construct can assume. I am on page 10-3 of our mini chapter. Let's make distinctions between different kinds of variables. First of all, what's the difference between quantitative versus a qualitative classification variable? First up, quantitative variable. Quantitative variable is a variable that reflects quantity or amount. Almost always the values that a quantitative variable assumes are numbers, and these numbers reflect amount. I've already given you examples of quantitative variables. Let's use IQ. Let's use income instead. Income is a quantitative variable. Your income last year might have been $10,000. It might have been $1 million. The values that it assumes are numeric scores, and those numeric scores reflect different amounts. A variable does not have to be quantitative to be a variable. I've already given you examples of non-quantitative variables. Let's give a definition for that type of variable. If it's not quantitative, it's probably a qualitative variable. Qualitative variable we also refer to as being classification variable. Qualitative variable is a variable that reflects quality or category, but does not reflect quantity, does not reflect amount. We're determining which category you're in, but we are not necessarily measuring an amount of anything. Examples of qualitative variables: subject sex, you might be in the male group, you might be in the female group, you might be in the non-binary group or some other group. That makes it qualitative, not quantitative. Political party is a good example of a qualitative variable. You might be in the Democrat group, you might be in the Republican group, you might be in the independent group. It's not measuring any kind of amount. So, big purpose of this lecture is to introduce you to our different schemes for classifying variables. One of the basic schemes for classifying variables is making this distinction between quantitative variables like income versus qualitative variables like political party membership. We come to another scheme for classifying variables. This is a biggie, and this is also a scheme that some students find to be kind of challenging. I am still on page 10-3, getting more toward the bottom of page 10-3. We come to a new subject: the 4 types of measurement scales, so-called Stevens 4 measurement scales. This is the classification scheme in which we think of a variable as either being nominal scale, ordinal scale, interval scale, or ratio scale. Before we get into those 4 different kinds of measurement scales, let's get clear on why this is an important issue. Why do you need to know about measurement scales? So that you can select the correct statistic for a given situation. One of my goals in this class is when you come out, I want you to be able to choose the correct statistical procedure for a given situation. If you conducted an experiment in Psych 305, for example, and you have a quantitative dependent variable, and you want to see if there's a difference between two groups, an experimental group versus a control group in this investigation, what's the right statistical procedure to use to analyzing that data? Should you use a chi-square test of independence? Should you use a t-test for independent samples? In order to choose the correct statistical procedure for that given situation, you need to know what scale of measurement was used to measure the dependent variable in your study, what scale of measurement is your independent variable on. That is among the reasons this is a super important concept in any statistics class. We are going to go over 4 scales of measurement. In order, they're going to be nominal, ordinal, interval, ratio. I'm going to begin with the most primitive scale, with the scale that provides us with the least information, and then I'm going to work my way up to the types of scales of measurement that provide us with more information, richer information. At the bottom of this hierarchy, we have the nominal scale of measurement. If a variable is measured on a nominal scale, it doesn't provide us with tons of information. If something's on a nominal scale, that means each score is simply used for identification and does not indicate amount. The variable that's on a nominal scale is a qualitative variable. It does not measure quantity. So nominal scale of measurement is nothing new. It's the same thing as a qualitative variable, which we talked about earlier in this lecture. Some examples of variables that are on nominal scale of measurement. These should sound familiar. I'm on page 10-4 now. Examples of variables on a nominal scale: subject, sex, political party, nation of birth. Were you born in the United States, or were you born in France, or were you born in Australia? Doesn't tell us any amount, simply tells us which group you're in. That means nation of birth is measured on a nominal scale of measurement. Let's put this in writing. I mentioned it before, but let's go ahead and take a note on it. Variables that are on a nominal scale simply indicate which group the subject is in. When it comes to subject sex, are you in the male group? Are you in the female group? When it comes to political party, are you in the Democratic group? Are you in the Green Party group? And so forth. When you see the word nominal, think name. So, of our 4 scales of measurement, nominal is at the bottom. It provides us with the least information. Let's move up one level to a scale of measurement that provides us with a little bit more information. I am still on page 10-4. The next scale of measurement is the ordinal scale of measurement. A variable that's on an ordinal scale does measure quantity in a very crude sort of way. With an ordinal scale, scores indicate only rank order or relative amount. Common way of measuring something on an ordinal scale is to rank order people, for example, from 1 to whatever. Whoever is ranked 1 has the most of whatever it is you're measuring. Whoever is ranked 2 has the next most of whatever you are measuring, and so forth. We use ordinal scale variables all the time. For example, the order in which people complete a race. If somebody placed first, you know that they were moving faster than somebody that placed fourth. Ranking photographs from most attractive to least attractive. You might give a bunch of photographs to a participant in investigation. Give them 10 photographs and tell them, I want you to rank order these photographs from the most attractive photograph to the least attractive photograph. When you think ordinal, think ordered. You're basically putting people in groups and then ordering those groups. You're putting objects in groups and then ordering those groups. On page 10-5, we start talking about the weaknesses associated with ordinal scale of measurement. What you heard me say at the beginning that I'm going to present these scales of measurement from the one that provides us with the least information, nominal, to the one that provides us with the most information, ratio. Well, what's wrong with things like ordinal scale of measurement, which is relatively low in the hierarchy? A weakness with the ordinal scale of measurement is the fact that there's not an equal unit of measurement separating each score. For example, in terms of time, the difference between the person ranked 1 versus the person ranked 2 may not be equal to the difference between the person ranked 2 versus the person ranked 3. What are you talking about? Let's move this up a little bit higher on the screen. Imagine you have a bunch of women marathoners completing a marathon race. You've measured how long it took them to complete the race in hours and minutes. Alice did well. She completed the race in 4 hours and 10 minutes. Betty came in much later. It took her 9 hours and 11 minutes. Doris came in just a little bit later than Betty. It took her 9 hours and 12 minutes. Now, if you were measuring their performance using elapsed time, that would be good. That would provide you with a fairly rich source of information, hours and minutes. Notice I've labeled this ratio scale. A little bit later in today's lecture, I'm going to talk about how elapsed time is on a ratio scale. It provides us with a lot of information, but we're not there yet. Right now, we're talking about things that are measured on an ordinal scale. What if I had measured the racing performance of these women, not in terms of hours and minutes, but just in terms of their rank in crossing the finish line? I would say Alice ranked first in the race, Betty placed second, Doris placed third. Notice this does not give me very much information. Notice if what I was using was ranking, there's not an equal unit of measurement separating each score. There's one unit of measurement separating 1 versus 2, one unit of measurement separating 2 versus 3. But when it comes to their performance in the race, the difference between Alice versus Betty is not at all equal to the difference between Betty versus Doris. If the only thing you had was their rank order, it's on an ordinal scale and you don't have much information. If you want to know how much better Alice did compared to Betty and how much better Betty did than Doris, you don't want an ordinal scale of measurement like ranking. You want ratio scale of measurement, which we're going to talk about a little bit later in this lecture. And I put that into words down below. With respect to time, the difference between Alice and Betty is not equal to the difference between Betty and Doris. Now, this might seem like, so far it might seem like a kind of an arcane issue. Who cares? Well, this business of measuring things on an ordinal scale of measurement does turn out to be a big deal when it comes to conducting research, because the problem with ordinal scale of measurement involves the fact that we have relatively few statistics that are appropriate to analyze data that are measured on an ordinal scale of measurement. It's better to obtain data that's on an interval scale or a ratio scale of measurement to be discussed below. I bring this up because there is kind of a common rookie mistake that a lot of students make in their first experimental psychology class when they designed their first experiment that involves this business of ordinal scale of measurement. Common example of a variable that's on an ordinal scale of measurement is scores on a single item rating scale. Most researchers, most statisticians will view these scores as being on an ordinal scale of measurement. What do you mean by that? Let's imagine you're conducting a study and the dependent variable in your study is motivation to win. You're doing some kind of intervention, you believe it'll have an effect on motivation to win. So you want to measure motivation to win in a sample of participants. You measure it using this single item rating scale. On a questionnaire, people see this stem. It's important to me that I win this race. They'll circle some number from 1 to 5, where 1 represents strongly disagree, 5 represents strongly agree. Now, with this scale. Higher scores do indicate higher levels of motivation. However, most researchers will argue that it's on an ordinal scale of measurement. This is because, with respect to the construct of motivation, the difference between a score of 1 and 2 is not necessarily equal to the difference between a score of 2 and 3. When it comes to measuring motivation, how do I know that the difference between the people that circled this versus the people that circled this is the same as the difference between the people that circled this versus this? If this is measured on an ordinal scale of measurement, you don't have equal differences between consecutive numbers. You don't want to measure something with a single item rating scale. You want to measure this variable with something that's a little bit more sophisticated that I am going to talk about in this lecture. Now, warning, in general, you should generally avoid the use of single item rating scales in research. If your data are measured on the ordinal scale of measurement, there's relatively few statistics that we can use to analyze those data. If the variable that you're measuring is on the ordinal scale of measurement, we don't have very many statistics. You might find yourself caught in a bind when it comes time to actually analyze the data. If you're conducting an experiment, you'll find that you'll do better if you instead measure your variable on an interval scale of measurement. That'd be a good place for me to begin the next lecture on this topic of Part 10 Variables in Research. So let's pause, let's stop this video at this point, and with the next video I will pick up with this topic, interval scale of measurement, on page 10-6 in your PDFs of mini chapters for Unit 1.